Let's consider this question from differentiation from the first principle. There is a question from WASSCE November 2012. That's question 3. It says, find from the first principles the derivative of 2x squared plus 3 over x with respect to x. So here we can say our f of x is equal to 2x squared plus 3 on x, or 2x squared plus 3x raised to the power -1 from indices. So here, by using the normal way of differentiation, we can say dy dx is equal to 4x plus -1 times +3, -3x -2. That's -1 minus 1. So from the normal way of differentiation, dy dx is 4x minus 3x exponent -2, or 4x minus 3 on x to the power 2. So now, using the normal way of differentiation, we know our dy dx is equal to 4x minus 3 on x exponent 2. So we can choose to write it here. We expect our answer from the first principle to be 4x minus 3 exponent x on 2. So the formula for the first principle is dy dx, or f prime of x, is equal to limit as h approaches to 0, in bracket fx plus h minus f of x all on h. That's the formula for finding formula for the first principle. So now our f of x is equal to 2x squared plus 3 on x. So now we need to find our f of x plus h. Therefore, our f of x plus h is equal to 2 multiply x plus h squared plus 3 on our x plus h. So here we are just the question from here, we just need to expand the expression given over here. So our f of x plus h is going to be x squared plus 2 multiplied by x and h, giving us 2xh plus our h squared plus 3 on our x plus h. So here we multiply through by the values over here. So we multiply 2 through the values over here. So our f of x plus h is now going to be 2x squared plus 4xh plus 2h squared plus 3 on x plus h. So okay, from here our dy dx is equal to limit as h approaches 0. Limit as h approaches 0, and our f of x plus h is known to be 2x squared plus 4xh plus 2h squared plus 3 on x plus h minus our f of x, and our f of x is known to be 2x squared plus 3 on x, all divided by h. Okay, so our limit as h approaches 0.
And the one I'm ready to work.
Bracket open 2x squared plus 4xh plus 2h squared plus 3 on x plus h minus 2x squared minus 3 on x all over h. So here we just need to subtract and add like terms over here. So 2x squared will cancel, 2x squared minus 2x squared is going to be giving us 0. So we cancel both out. And then 4xh, 2h squared. So here we can't subtract or add any like terms over here. Limit as h approaches 0 is going to be 4xh plus 2h squared. So here plus the fractions over here, we need to find the LCM of the fractions over here. That's 3 on x plus h and minus 3 on x. So here our LCM for this fraction is going to be x bracket open x plus h. LCM is now x multiplied by x plus h. So here the x plus h cancels the x plus h, making it 1. Then the remaining x will multiply the 3 over here. So now you get 3 multiplied by x as 3x minus, don't forget the minus sign, minus. So here the x cancel the x over here, remaining the x plus h. Then you multiply the x plus h by the 3 over here. So to be 3 bracket open x plus h, all divided by h. Okay, so we still need to further expand the expression over here. So our limit h approaches 0 is going to be 4xh plus 2h squared minus, plus 3x. Negative 3 times x gives us negative 3x. And negative 3 times h gives us negative 3h. All on x multiplied by x plus h. All on our h. So here we can see some like terms you need to subtract and add over here. So here our 3x minus our 3x gives us 0. So definitely we will cancel our 3x and negative 3x from the question or the expression. So here, let's see if we can find another like term we can cancel or add. 4xh plus 2h squared, 3h. We can see we cannot do anything about it. So we continue by saying our limit as h approaches 0 is now 4xh plus 2h squared minus 3h on, then we expand the expression over here. So x times x gives us x squared and x times h gives us xh, all divided by our h. Don't forget. So here we just divide each expression by our h. Okay, so now our limit as h approaches 0 is going to be 4xh on h plus 2h squared on h minus 3h on x squared plus xh, all divided by h. But from the law of indices, we can say 3h on x squared plus xh multiplied by 1 on h is the same as all divided by h. So here, just need to do some small cancellation over here. So here, h cancel h, here to h cancel h, remaining 1, and here h cancel the h over here. So now we can say our limit as h approaches 0 is going to be 4x plus remaining that one 2h minus 3 on x squared plus xh. Okay, so now as we can see, as h approaches 0, we therefore substitute 0 to where we find or we see h. So now 4x plus 2h, so 2 multiplied by 0 from substitution, minus 3 on x squared plus x multiplied by 0. So here 4x, 2 multiplied by 0 gives us 0. So therefore negative 3 on x squared plus x multiplied by 0 gives us 0. So from the first principle, we can say that the answer is going to be 4x minus 3 on x squared. From the previous answer we got from the normal way of solving differentiation. Thank you for watching this video. Share, comment, and like. Give a like as well. Bye bye.